All right, 1-4 in geometry, and things a little different because I need to show you how to do some stuff on your geometer. Today we'll be measuring an angle. So if you see right here in question number 1, which should be not number 3, but 1, it says, what is the measure of angle BAC? And that's new right here because we have this little M in front of it. That M stands for they're asking us to measure an angle. We're always going to measure our angles in degrees. There are other ways to measure angles, like called radians, but here we do degrees in geometry. Well, what we'll use is on our geometer, we've got our protractor right here. There's two main parts to that protractor. This thing right here, I call him the whole of the protractor because he's what we use to measure off of. And then you see this guy right here is pretty fancy. He's the only guy that's got the black arrowhead on it. So to measure an angle right here, we're going to place the whole of our protractor on the vertex, and then at the same time, the black arrow on top of that ray right there. So I'll get that on there, get it all nice and lined up. Do you see how I'm kind of not on that black ray? Right here, I got to get it right there. And I just read my protractor where it is, which can be very difficult to read, but it's not that bad. You just kind of got to look for the big numbers. You got your 30 and your 40, and we're right here on that tick mark in between, so that's 35 degrees. Now, everybody's eyes are a little bit different, so if you're off by a couple of degrees, that's okay. You can have anywhere from 33 degrees to 37 degrees, and I would still mark that correct. So that's how to measure an angle with your protractor. To draw one, as you can see on the next question here, they say draw angle XYZ that measures 80 degrees. First thing we'll do is use just our straight edge to draw a ray right here. So we'll draw a ray with a straight edge, just like so. Then what we'll do is we'll put the whole of our protractor right here on the end point of our ray that we drew, and at the same time, black arrow on top of the ray that we made, like so. Getting it all lined up. They wanted to measure 80 degrees, and of course, it just so happens where 80 is, I can put this little tick mark, but it went right through those instructions. That's okay. No big deal. Put yourself that little tick mark right there. If yours didn't get there, that's good for you. But then all you got to do is remove the geometer and connect from the vertex of your angle right through there. And then they wanted that to be 80 degrees, so I'll put that on the inside. They wanted its name to be angle XYZ, so that means since Y is in the middle, Y has got to be the vertex. X is on one of the rays, Z is on the other in that case. So this is angle XYZ that measured 80 degrees. You might remember the three different types of angles that we've had. We've got ourselves a right angle. That's if the measure of that angle is 90 degrees. And you see that little box right there? We call him the right angle box. Like, that's how you can mark him. You can also put 90 on the interior. Then if an angle happens to measure, if this is the measurement, if it's like bigger than 0, but at the same time less than 90, he's called acute in that case. And then if that measure is actually more than 90 but less than 180, then that's going to be an obtuse angle. These are the three angles that most textbooks talk about. I also talk about a zero angle and a straight angle. The straight angle is more important in this course. The straight angle measures 180 degrees. So like if I was to draw this guy right here, maybe this guy right here, and put like an A and a B and a C, angle ABC, if I've got ray BA and ray BC, that's nice and straight. Well, that's always going to measure 180 degrees. And that's one of the basics of geometry as well, that anything that's on a straight line, aka a straight angle, measures 180 degrees. Can't ever measure more than that. And here to use our protractor to measure all these different angles, well, first of all, if you see when I put my protractor on top of there, like these arrowheads, they don't reach the numbers, right? So that's not good. We're going to have to guess where that is, so we don't do that in geometry. We don't guess. We're going to take our straight edge and extend these guys out. So just connect nice and neat. I wish I could do this a little bit faster, but I'm trying to balance around a camera. We're going to make it. So we'll extend these guys out much longer. Slipped a little bit there, my bad. Try to be accurate with it. So then they ask us to find all these angles. Well, I'm a highlighter guy, especially since this is very, very new. Sorry that I keep bumping the camera, but angle MPR is what they want me to find first. So if I highlight that green, I can go find him in the picture really, really easy by just tracing from M to P to R. And this is not something you have to do. You don't have to highlight this, but a lot of people struggle finding angles. So to find it easy, highlight it and just connect the dots. Then to measure that angle right here, put the whole of our protractor on the vertex, just like we did before, black arrow on top of line PR, and then get it all lined up and see where she measures to in this case. And I got mine to be pretty much right on the 120 degrees, right? It is possible that that doesn't land on like a multiple of 5, you know, it could be 122 degrees or whatever, but mine I got to be 120, so I'll classify that as either acute, right, or obtuse. He is obtuse because he is bigger than 90 degrees and less than 180. To find the measure of angle RPN, I'm going to go find him in this case from R. Let's use it in the camera screen also. From R to P to N. So there, I found him in this case. And then to measure him, well, I could put my protractor on there and get it all lined up. And it just so happens that that thing lines up like perfectly with the 90-degree mark. And honestly, I think we could have told that without having to measure it. That's a right angle. And we'll answer that down here because of this right angle box. We'll come back to that here in a second. But we knew that was probably going to be 90 degrees because they put that there for us. So then the last one, they say find the measure of angle RPS. So if I say, okay, there, I'm going to find RPS. Again, you don't have to highlight. This is just, if you struggle finding angles, highlighting them is very, very, very easy way to say, okay, I can see them better. So we'll put my protractor on top of there. And then we'll get all lined up, and I got mine to be right at 45 degrees, right? So like I said, they don't always come out so nice. You know, you can have like 47 degrees or anything like that. If you're within 2 degrees, I give you correct. So 43 to 47 would work, and this is acute. So we're back here, baby, and we got that acute angle, and the main reason is why we could have done that number 8 is because it had that right angle box. Right? If you ever see that right angle box, you don't need to use a protractor to measure the angle because they're straight up telling you, bro, this is 90. Then the magic word of the day is congruent angles. Congruent, remember it meant same size, same shape. Well, when we're talking about angles, congruent angles are angles with the same measure. Angles with the same measure. And if you remember back to when we did congruent segments, we marked them with tick marks. We don't use tick marks for any angles. We use arc marks. So if you look at the picture I have at the right here, I have a red angle and I have a green angle. Do you see those little swoops inside of there? Those things are called the arc marks right there. And the same amount of arc marks means that they measure the same. You can have an angle right here and an angle right there to where this has double arc marks and that has single arc marks. Those don't measure the same. They're not congruent. They have to have the same. Now, if they both had double arc marks, then bada boom, they are congruent. So just like segments were picky, 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 so are angles. If you use an angle symbol, then you have to use a congruent. The angles are congruent. They are the same size, same shape. But their measures, like 45 degrees or 72 degrees or whatever, the measures are an equal symbol. So picky, picky, picky. Can't use a congruent sign and an M at the same time. If you don't use an M, you got to use a congruent sign. And we'll get so much better at that as we go along. But as we go through, then we talk about a bisector in that case. A bisector cuts things into 2 equal pieces, right? So it's either a line, ray, or segment that cuts an angle into 2 congruent angles, right? It's going to bisect. Bi means 2, like a bicycle has 2 wheels. Sector means section, so 2 equal sections in that one. So here's what we'll do. I'm a big believer in this. Let's do some highlighting. So we'll need like 2 different color highlighters right here, but it says, given the measure of angle EBF is 6x plus 4. So geometry is going to work a whole lot better for you if you learn to just put stuff in the picture. I'm going to highlight angle EBF and then go find him. I just traced from E to B to F, right? And then what we're going to do is we're going to put this 6x plus 4 in the picture so we can see what's going on. So I got him taken care of. They gave me that information. They also gave me the fact that angle CBF, I'm going to switch colors here, bro. Measure angle CBF. Can you also see I just noticed that they didn't put the little swoop with that symbol? Sometimes they don't put the swoop. I'm not a big fan of that. If you ever draw it out, please put the swoop with it. I think that is better because it doesn't look like a less than sign. But the measure of angle CBF right here, that's this red one. I just traced from C to B to F to go find that guy, 7x minus 2. And right now, that's all we know until we read the magic statement down here that's going to tell us what to do. They say ray BF bisects angle CBE. And the magic word there is bisects it. So here's angle CBE. You don't have to highlight that a third color because it just makes things messy, but I'm just showing you. Here's angle CBE. Here's ray BF. That guy did this. It cut that into 2 equal pieces. So what I need you to do, you just do this with pencil now, is you mark that angle the same and that angle the same. You put those arc marks in there, and I like to stagger them as opposed to just putting this one big swoop right there because it looks like you're only talking about that one angle. It's like I want to know that we're talking about angle 3 and angle 4 in that case right there. So that's what the bisector does. And remember, it cut them into 2 equal pieces. So long story short, those two guys should be equal to each other. The green one was 6x plus 4, and that's going to equal the red one, which is 7x minus 2. And we could use algebra. I'll put a 2 there instead of a 7. We can use algebra to solve for x. So my first move is I'm going to subtract 6x from both sides. So 4 will still be here. Equals is right there. 7x take away 6x is 1x, and then there's a minus 2. And then finally, I will get rid of the minus 2 by adding 2 to both sides, and I got x to be 6. Well, that's not what they asked, right? They didn't ask for that. They said find the measure of angle EBF. That's where we'll use some substitution right here, and since x is 6, I will substitute that back in and do 6, clear, 6 times that 6 that was x plus 4. It's been a while since you may have done this, but you see how where there was an x, I just substituted 6 in its place, and that turns out to be 40. So this guy right here is 40 degrees. That's the measure of that angle. And just for a little check, if we put 6 in here, we better get 40 degrees back because aren't those two supposed to be equal? So 7 times, 6 plus or minus 2 in that case, and bada boom, we got 40. So we did our algebra right in that case because those two were supposed to be equal. And then the last one of the day, baby, sorry, I got to kind of skip through all this. The last one of the day is they say the measure of angle PQT is 60. So here's where we get a little tricky. PQT, if I highlight him, if I go from P to Q to T, there's like another array inside of there. So like where do you put the 60 degrees at? I like to put him way out here on the outside. And honestly, I'm kind of a silly dude. I call that big swoop right here, I call him the big old honker McGee right there because that's saying that entire angle right there is 60 degrees. Then this guy, angle PQS, from P to Q to S, 4x plus 14, so I'll put that in the picture. Yep, you got to have all this stuff in your picture to get all your points for me. Then it says ray QS, that's this guy, ray QS, bisects angle PQT. Again, that blue stuff you might not need to highlight because it just starts making a mess, you know, but it's like just, I like to show you guys what I'm doing. So if that got bisected, here's your job, man. Your job is to go put arc marks. If an angle gets bisected, bada boom, bada boom. And remember, the arc marks mean that these two guys are the same. But the weird part is we don't have anything, sorry, I hit the wrong button. We don't have any representative for this. We know this little piece down here is 4x plus 14. What's the orange piece? Well, brain says, Mr. P, if this whole thing is 60, and these is cut into 2 equal pieces, then can't we just take 60 and divide it by 2 and call each one of these 30 degrees and 30 degrees? and I say winner, winner, chicken dinner to that, you can totally do that because that's what a bisector means. That's the definition of a bisector, is it cut it into two equal pieces. So what could we do algebraically to solve for x? Well, honestly, this part we don't even need anymore because don't we know this is 4x plus 14, like as an algebraic expression, and it's also supposed to be 30, so how about we just say, hey, 4x plus 14 is like supposed to be 30, supposed to be taking place by the equal sign right there, and we do ourselves some algebra. So I'm going to subtract 14 from both sides. Again, you can always use a calculator, so I'll do that for you. 4x should equal 16, and then if I divide by 4, divide by 4, x should equal 4 in that case. And that's all they wanted, is to find the value of x, so we got her, man. Pretty cool. Bisector cuts it into two equal pieces. Hey, let us know if you have any questions, man. Have a good one.